So, in this section, we've got a couple different types of, there's a lot of definition, a lot of vocabulary, and we just got to get us all on the same page here. So the first thing that you know is there are two types of variables that we will discuss in this course. The first type of variable that we will discuss is called qualitative variables. The root word of qualitative is quality, okay? So it's going to be descriptors. Most of the time when we talk about qualitative variables, we're talking about words that can be used to describe in some way. The definition from the book, they can be placed into distinct categories according to some characteristic or attribute, and some examples might be eye color, religious affiliation, and there's many others that you could use. At the very end of the notes today, there's going to be a way to sort of look at a table to differentiate some of this information that I think is helpful. I'm willing to bet you know the other type of variable. Anybody want to take a stab? Yes, ma'am. Say it again. Quantitative, that is correct. That means numbers. Quantitative, quantity. So quantitative variable means those variables represent some type of number. They can be ordered in an order. They can be ranked. But there will be a number associated with a quantitative variable. There are two types of quantitative variables. So we'll break those down into some subcategories on the next screen. Okay. So just quantitative we separate into two other categories. The first one is discrete variables. These are variables that can be counted using whole numbers only. You can count them like you were counting, like you were the Count on Sesame Street. Do you know what the other one is? Discrete and non-discrete. Yes, that's correct. No. No? Any ideas? Continuous. The other type of quantitative variable is a continuous variable. They all kind of can be thought of as within some type of interval. You measure it. Weight is an example what we measure with a scale. Height could be measured on a different type of scale. You can't just count it. There has to be meaning in between each of the whole numbers. So that's continuous. Because of the fact that continuous variables, quantitative variables, can not have holes in between their measures, we have to think of them in terms of intervals or boundaries. And so anytime we see a value that represents a continuous variable, we make the assumption that has already been rounded. Okay. And because the data has to be measured by some type of device, whatever the display of the device that it tells you, the value, it has to be rounded in some way because the device has some type of limitations, okay? If you get on a scale and you don't have a tenth of a pound on a scale and it just puts everything to the nearest pound, we know that every person that stepped on that scale would not be exactly equal to that weight. If your scale only rounds to the 10th place, my scale at home rounds to the 10th place. I know that I don't weigh exactly to the 10th of a pound, right? There's more or less mass than what is actually displaying on that scale. So we have to assume whenever you see continuous data that it has been rounded to some level already, which is why we actually think of continuous data in terms of boundaries. And I'm going to show you how to come up with those boundaries here in a second. And the key thing is, assume that whenever you have a number from continuous data set, that it's already been rounded. Assume when you're looking at continuous data that it's already been rounded for you. I will admit that the explanation that I'm about to give you for how to come up with the boundaries is not great. It's easier to understand what it means when we do an example. And after this screen, I'm going to have 3 examples of data that came from a continuous number set that we are going to find boundaries for. And then this explanation will make more sense. I'm going to give it to you anyways. And we can see if we can try to make some sense of it. Boundaries are given with 1 additional decimal place beyond the number that they gave us, and they always end in a 5. Like I said, it doesn't necessarily make sense on its own, but when we look at an example, it'll make more sense. Look like here's examples, okay? So you're gonna in some of your homework is gonna do find the boundaries. So what you have to understand here is that all 3 of these numbers have already been rounded. Essentially, the way you should think about it is these numbers are in the center of the boundaries. So we want to go a half a decimal place above and a half a decimal place below. And it's adding that 0.5 or 0.05 or 0.005 or 0.0005 and subtracting it as well. That's really what you're doing here, okay? So for example, if I went half a decimal place above 73, where would I be? 73.5. If I went a half a decimal place below 73, where would I be? 72.5. The boundaries for 73 are 72.5 to 73.5. We believe that that rounded number 73 is going to fall within that range. Okay? Does that make more sense? I told you it would. All right, do B and C. See if you can come up with the boundaries for those. They should be written in that form. Okay, this sort of interval form like this. That's how you want to write it. Say that again. You're extending the number an extra decimal place beyond where it is. So again, like on the first one, it was a whole number, but I added a decimal place. This one already has a decimal place, but I need to extend it to another decimal place. So what are the boundaries going to be for B? What's the upper boundary going to be? 3.85. So I went a half a tick above that. What's going to be a half a tick below? 3.75. Okay. How many had that? 3.75 to 3.85. So again, the key thing to finding boundaries is you add a decimal place for the boundary. And it's going to be 0.5 above and 0.5 below. Now, in B's case, it's 0.05 above and 0.05 below. In C's case, it's going to be 0.005 above and 0.005 below. Let's go ahead and finish that one. All right, what do you got? What's the lower boundary?
11.115.
Okay, upper boundary?
11.125.
How many had that? Questions on it? Okay. If you didn't get it right, write it down correctly and study it a little bit and see if you can make sense of it. If you still can't, see me and we'll get it straightened away. Okay.
So for C, you just subtracted 0.005.
Right. So really what we're doing on all of these is I'm adding a decimal place. And here I'm adding a decimal place. Every time I add it to the end, so it might be easiest to just tack a 5 on the end of it for every one and get the upper boundary first. And then the lower boundary is you're going to subtract 1 from the last digit that they gave you. So you see what I'm saying, how trying to put that all in words would have been terrible? So I subtract 1 from the last digit that they gave us, and then there was a 5 after it.
Oh, that's all you do?
Yep, that's all you do. Like I said, if I would have tried to write all of that out in notes, it just wouldn't have made any sense. It would have been so super wordy.
Yeah.
And I couldn't really come up with a better way of an explanation other than the way I did that tried to keep it concise. But again, if you're still not clear on that, see me and we'll get it squared away, okay? Questions before I move on to the next thing? We need to talk about measurement scales. And there's a bunch of vocabulary here. And in the measurement scales, there will be a table at the end so you can help kind of get an idea what goes into which category. Because there's a few of them that are super easy. There's 4 measurement scales. 2 of them are sort of really easy to understand, and 2 of them can be confused for one another. So, as I already said, there's 4. There's 4 of them. So, here are the 4 types of measurement scales. 1, a nominal level. 2, ordinal level. 3 is the interval level, and 4 is the ratio level. And we will define and give some examples of all of those. And then, like I said, on the last page, there's a nice little table that kind of categorizes all of them for you. Makes it a little easier to understand. Here's the nominal level. Classifies data into mutually exclusive categories. That means, mutually exclusive means each category does not affect the other. No order or ranking can be imposed on the data. Typically, nominal level is going to be a descriptor. Political party, for example. If you're a libertarian, you are not also a independent. Those are separate from each other. Ordinal level is you put things into categories that can be ranked. There is order, that's why it's called ordinal. Letter grades, for example, there's a ranking to it. Next. Oh, I put more, sorry. One of the things, the precise differences between some of the ranks do not necessarily exist. And this is a good example. Small, medium, large build, right? I mean, if you wear a large shirt, somebody who's a little bit bigger or a little bit smaller than you might also wear a large shirt. So although there's a difference, it doesn't have to be a gigantic difference. And we don't really think about it that way. And I don't know why there's an end parenthesis there. So let's get rid of it. There we go. It is gone. Interval level ranks data, and precise differences between units of measure do exist now. So in the ordinal level, they didn't, right? There's no meaningful zero. Temperature, for example, 0 degrees does not indicate an absence of heat. There is some heat, there's just not a lot of it. Right? Some heat exists. And you can kind of think about that as continuous. So kind of a good way to think about interval level. Literally, it's an interval. So there's going to be values all along the way. Ratio level assumes all characteristics of interval, but there is a true zero. So this is where these two can get kind of confusing, because you feel like they might be the same. And this whole difference between a meaningful zero and a non-meaningful zero can be kind of confusing. And this is where the table that I'm going to show you in a second is going to come in handy. I think the difference between nominal and ordinal is something that you're going to be able to deal with fairly easily. This is the one that's a little more tricky. So again, you can take a picture, you can screenshot, it's up to you. But notice here, I really want you to pay most attention to these two categories on the right. Because these kinds of things will always fall in interval. These kinds of things will always fall in ratio. You'll want to study those. You'll want to make sure you have that squared away for the quiz tomorrow. Okay? I think these are pretty easy. Anytime you're ranking or rating something, you're talking about ordering. It's an order of something. Okay? When we're talking about descriptors or characteristics, things that are separate from one another, that don't impact each other, right? If you live in 33919, you live in that zip code. You don't live in 33991, unless you have more than one home, and but you know what I mean, okay? One home cannot be in two zip codes. That makes them exclusive. These kinds of categories, nominal, ordinal, putting them in order, keeping these two straight, it's probably better just to pay attention to the table, okay? Any questions?